Hello. In this video, I will present you the Lands Design, the professional software of landscape architecture, which works inside both programs of AutoCAD and Rhino. I will show you its main features. First, let's know what exactly it is. Lands Design is a professional software with BIM technology, which lets you produce 2D drawing of your landscape project, model it in 3D, generate dynamic documentation with quantity takeoff of the plant species and hardscape elements existing in the project, and finally, produce photorealistic images and visual tours to present your project with the animation tools. Lands Design is a useful tool in the fields of landscape, green infrastructure in architecture and civil engineering, urban planning, and environmental projects. So, why to choose Lands Design? Let's see its main powerful features. First, the extensive plant database in 3D and 2D provides filters to help you select your species according to its form, climate, the soil, and other characteristics. There are different representation modes for any species: realistic, detailed, conceptual, and elevation mode. You can modify any plant characteristics and 3D model of any species by the plant editor inside the program. In Continue, you can save the modified species as a new model or as a new species. You may have different representation modes just by one click: conceptual, detailed, realistic, and 2D. Lands has powerful terrain modeling tools. Terrains can be created from 3D curves, points, clouds, or a mixture of them. Later on, you can do lands operations such as cut and fields, pass, hole, or divisions that can be easily edited through control points. The volume and area of land movement in these operations can be reported in quantity takeoffs. Lands Design also provides a tool to import terrains from the web. You just need to specify the location on the map and import the terrain with the scanned elevation data. The same tool lets you import a texture mesh with the satellite map of the scanned area. Another feature is dynamic 2D documentation. From the 3D model, you can produce quantity takeoffs with the species existing in the model, urban furniture blocks, land operation, and other elements. You can add image of the species and finally produce the 2D plans, sections, and elevations of the project. There are also some irrigation tools that let you define the irrigation system of the project and quantify the number of pipes, sprinklers, drippers, and their data. Hardscape tools in Lands let you to easily create parametric walls, curbs, paths, and fences, and add furniture. Finally, Lands have a set of visualization tools for animated videos and realistic images, including walk mode, virtual simulation, sun and shadow tools, etc. The design process with Lands Design is summarized in this short video. As you see, you can import terrain by looking for its location on the map or generate it with lines and points. Once model the terrain, you can modify the terrain. You can zonify the site and it gives you the area, and you can define it with different hatch and assign material to the different zones. You insert plants in different arrangement, individually, in a row, in forest, etc. You may even apply natural variation option in order to all the plants don't be in the same size. You insert hardscape elements, walls, fences, and blocks. You can easily change from 3D to 2D at any time just by one click, and then you modify the design by control points. Then it generates the list of plants, furniture, irrigation, and finally you can render the project. The Lands Design workflow is summarized here. You can start drawing in AutoCAD or Rhino, or import land data from GIS, and then develop the design by modeling and documentation in Lands. And finally, you can render it and export data to work with other programs.
Hello, let's take an overview of Lands Design main features. We will basically see what we have seen in the presentation with a live demo. So after installing Lands Design for AutoCAD, we will get this tab with all the Lands commands available. Okay, we can also search for any specific command in the command line starting by LA. Okay. Now, we can see here that we have got a command to open the plant database. We'll see that later on. Some commands to insert vegetation elements that can be inserted individually, arranged in rows, in forests. We can insert them in the paint mode, or we can also insert vegetation elements in the shrub or ground cover option. Then we've got some tools for civil work objects, such as walls, fences, stairs, paths or rows of elements that we can search in the block library. Then we've got some terrain modeling tools, so we can generate terrains from 3D curves, 3D points, a mixture of this geometry, or importing them from the web, as we have seen in the presentation, and all the rest of commands to do operations on them. Okay, we can add contours, we can define the boundary of the terrain, we can add holes, divisions, cuts and fills, and paths. Okay, and all this information will be stored in the terrain. We will see how it works later on. Then we've got some irrigation tools to insert sprinklers that can be arranged in arrayed mode, or pipes. We've got a command to display the plant shadows, some other documentation tools to list all the elements that we've got in the model, such as plants, sprinklers, pipes, zones, or your-own blocks. Also terrain, the terrain land movement can be listed in a table. And then some other commands to add labels for the plants, pictures, dimensions, elevation marks, labels, or slopes. Also, we will be able, with this command, the Zonify, to define the areas of the project. Finally, we've got some other commands to open the edit panel, which we can see here, and it's divided in two different tabs. One for editing all the elements we'll be selecting in the project, and another for defining camera path and recording some animations. Okay, we'll see that at the end of this webinar. Then we've got a command to set viewpoints, okay, or put you in a walk mode that will let you navigate over the project interactively. Also, Lands Design integrates an image editor that will let you import images and apply effects already built in AutoCAD. Okay, but let's take a look first at the Lands Edit panel. This is the most important dialog in the program, and here we will be able to display all the elements that we've got, but also modify any detail. So when nothing is selected, we can see the document properties, and here we can change the different representation modes for the plants. For example, now we've got the realistic mode, but we can switch to elevations, okay, or we can switch to conceptual, detailed, or back to realistic. Also, this mode has two representation modes, so it has a 3D and also the wire representation. In both cases, if we were to render this scene, this 3D representation will be replaced by the realistic plan, so we'll get a good quality render result with a realistic representation of the plant. So since this is a small project, I will leave this in 3D, but if you're going to work in a large project with a big number of plants, maybe it's a good option to use this wire representation. Also here we can determine the season of the document, and basically from here we can change the season, which will determine how the plants will look like in the final render. Okay, since this representation mode can handle different appearances that are assigned to different seasons. We can see that later on when we see the plant database. Also, if we're going to work in 2D, so I'm going to move to the top viewport, we can switch to a 2D representation. So basically, all the elements have both 3D and 2D representation. So the plants have this 2D crown, okay, which actually can be switched to setting out symbol. And the other elements, for example, the zones, are represented with this with a hatch pattern. Okay, the ground cover also with a boundary and also can have a hatch pattern assigned. All right, and terrains are represented with contour lines. We will see that later on. So basically, you can work on 2D with land elements, give you the feeling that you are just working in 2D, but at the end of the day, you will get the project in 3D. So I'm gonna switch to 3D view now and insert the plant. So we can run the plant command over here, which will display a list of the species that have already been used in this project. Okay, or we can search for a new one. So I'm going to browse for the plant database, and here we get the list of all the plant species that come with the program. So we can just navigate over this list to search for the desired plant. And just notice that some plants have a colored representation and others don't. Okay, basically those that don't have a specific realistic representation will show up here in this gray color, while those that have already a specific realistic representation or detailed representation according to their appearance, they will get this preview in color. So basically from these filters we can search for one specific plant species just by designing some criteria according to the leaf type, the plant type, and all these details. Or you can use the search field, for example, to look for a lemon tree. Okay, so I can just search from the list and find the proper species. Now, if we want to check all the features of these species, we can open the properties, and here, selecting this edit button, we will be able to change the details of this species. So we can navigate over these tabs to change the morphology details, characteristics, or also the display blocks assigned to this species. For example, for the 2D drawing, we can browse for the library of 2D blocks available, okay, that we can use for the plant crowns. These blocks are basically a collection of files stored in that folder. So if you have your own 2D representation, you can also put it there and use it for the 2D representation of any species. Okay, I cancel this by now. And actually, from the render tab, we've got here the option to assign this realistic NXT plant file, which is the one that handles different representations according to the season. We've got several of them. Or you can generate these files from the plant editor. So if we launch it from this button, we can already play with the file assigned to this lemon tree species. Okay, so we can just play with all these parameters until we find the proper appearance. Okay, we can also change the material assigned to the trunk, or the material for the leaves, or material for the fruits in this case. So we can play with all these values to find the proper appearance of the plant. And actually, once you have finished, you can create a new definition and assign this representation to it. This model actually, it has already 4 definitions, each one assigned to different seasons, so we can see the different results selecting them. And when we shutter render, according to remember the document season, this plant will render in one way or another. Actually, we can also create new plants, new NXT plant. There are a few templates available. Okay, so you can just open a new file and play around with all these values. Finally, save this option, the result, as a new file type and assign it to a new species. Okay, I'm going to say no here, cancel this by now, and actually from here you could create a new species, which will show completely empty template to be filled with all the details of the new species and also all the files for the 3D representation. All right. Now we've got this species selected. I'm going to select it. Define here the insert details. So here we can define the height, and just click OK and insert this into the scene. Now, once it is inserted, we can select it, and from the edit panel change, for example, the size of it. We can change also the species. All right, so we can do any modification as we wish. Okay, but let's switch to the top viewport. I'm going to work in 2D now, because some of the first steps in the design process of any project is basically defining the areas of the project, right? So we've got the 2D guidelines of the project design, and we use them to define the different areas and see the total area of each region. So I'm going to use the Zonify command for that, which let you select an area just picking one point inside it, or selecting this limits option in the command line. So we can select this rectangle. So I'm going to call this playground, define some hatch pattern, okay, some color, some details, and finally we can also assign a material for the 3D representation when we switch to 3D. And here, well, Lands Design provides a library of materials, okay, that we can use for the different elements available in the project. Okay, we can change the reflectivity or transparency, but if you have your own material according to the render engine that you're using, you can also select it from here. So I'm going to insert a title here. If this is too big, we can change, the value from here. Let's say playground. All right, and when we switch to 3D, we will see also the material on top of this area. All right, let's go back to 3D view, and let's take a look at the terrain modeling tools. So in this case, I'm going to use these curves that we've got here to generate the terrain, which is a common situation, okay, if you get a DVG file where there are all the curves of the terrain. All right, but as you can see, all these curves are in the same plane. So the first thing I will do is to elevate them according to an incremental. And I will use this command for that. Elevate curves. So basically, I need to draw a line, and all the curves that intersect with this line will be elevated according to an increment. So if we put this 2 meters and click apply, I can preview the result here. Okay, maybe this is too much, so I'm going to put this back to half meter. I click apply to see the preview of changes, and close to accept the changes. So I've got now the curves in the right position. So this is ready to create a terrain. So let's run the terrain command. This terrain is basically a mesh that is generated using this Delaunay triangulation method, but I can also choose this gridded surface shape to triangulation option, which basically will let me define a cell size to control the accuracy of the result. Okay, let's try with 1 meter by the cell size. Click OK, and now I just need to select all these curves, but not this one. Okay, I hit enter, and now the terrain is generated. I've got these contour lines in one specific layer that I'm going to turn off. Now, when we switch to 2D representation, move to the top viewport, I'm going to show this in 2D, we can see the terrain is represented using these control curves. If I select these contour curves, I can modify the topography of the terrain. All right, so I have control of the terrain topography just by editing the same control points as the curves used to generate the terrain. Also, from the edit panel, I can change the settings of these contour lines. This is already set to total number of contours, but I can switch to distance between contours and say I want them to be every 20 centimeters. Okay, and also I can enable this index, so I get a better feedback of the contours. There we go. So basically, the text size maybe is too big, so I'm going to put this to 0.5. Okay. There we go. If we want to see the 3D representation and 2D representation at the same time, we can do it with this option over here, Show 2D and 3D, which will give a better feedback of the terrain relief. So another thing that we can do is, well, trimming the terrain according to some limits. For example, I've got already this curve, okay, this rectangle, and I want to trim out all this part of the terrain that is outside of this boundary. I can use this pick boundary command to select the terrain first, and finally this curve as the limits, okay? And the terrain will be adjusted to this area only. Let's take a look at this terrain in 3D. Okay, I'm going to show the 2D and 3D representation at the same time. And now I'm going to show a layer where I've got a curve, the auxiliary layer, and I will use this curve to generate a path. Okay, let's see this in 2 wireframe, because here I've got this curve in blue color that will be used for the terrain path. This curve is currently located in the XY plane. So the first thing I need to do is project it on top of the terrain surface. Okay, I could also pull these control points up to define the position of the path, and when I add the path on this terrain, the terrain will be adjusted to it. But as a first step, I'm going to use this Adjust to Terrain option to project the curve on top of this terrain, as you can appreciate. Now, let's put back these to realistic. And now I can run this terrain add path command. So I'm going to select the terrain. I'm going to define a width of the path, let's say 2 meters. And finally, a slope along the path with the terrain. Basically, will determine the angle in which the slope will meet the terrain. Okay. All these details can be edited afterwards. All right. So I'm going to click Enter, and finally, you need to select a curve. So I will pick this curve, and the path has been already added to this terrain. Maybe now it's difficult to appreciate, but maybe you can see that we've got a subdivision on this terrain. And actually, if we select this subdivision from the Edit panel, we can change the material on it. So I'm going to choose a different material for this area of the path. So I'm going to go to Site, and here select this material, for example. There we go. Now if we select the terrain, we go to Input Data, and we've got here all the geometry that has been used for generating the terrain. So we could select this boundary and remove it, okay, to get the original shape, or we could select any of these contour lines and remove them as well. Or I can select the path and change the width or change the angle, and the terrain will be recalculated. All right. Let's now insert some more vegetation elements. Okay, I'm going to work from the top viewport, and also in wireframe display, just to see this boundary that I will use to generate a forest. So I'm going to run the forest command. I need to select here some species. So let's choose this Acer platanoides, define the height of them. Here you've got this option, natural variation, which will make the plants not be exactly the same height. So their height will vary according to a percentage from the specified height. And under the forest tab, we can define the information of the forest. So basically the number of units, okay, the minimum distance among the units, let's say 1 meter, for example, or if you want to arrange them in an ordered way, in an array way. We can see that later on. Okay, first I'm going to click OK. Here I will select this limits option in the command line, just to select this curve. And as you can see now, maybe we can see this in 2D, all the forest has been inserted. If you don't like this distribution, you can just select forest and redistribute as many times as you wish. Or you can go to the forest tab and change the arrangement using this array option and say that I want units every 3 meters. If we put this back to 3D and we see it from the 3D view, I'm gonna just unselect it, you can appreciate that the plants have been projected on top of the terrain. If some of them have not been projected correctly, you can always select them and go here to adjust to terrain. Okay. Now, back to the top viewport, I'm going to insert a ground cover. All right. So I will run this command. I will select some species from the plant database which have already one specific representation for ground covers, okay, which are different than single plants, and just select any of these species. This one, for example, define the details of the density or the plant scale. Also, the ground covers are represented in 2D using hatch pattern. All right, and finally, after clicking OK, I can just draw them using any of these options or selecting a curve. Okay, I'm gonna use the rectangle option and draw the ground cover on this area. If I take a closer look, I can select this, okay, and I will switch to wireframe because I'm gonna change the boundary just by modifying the control points of the curve used to generate these limits. Let's go back to realistic and take a look at the project in 3D. As you can see, all this ground cover has been projected on top of the terrain. Okay, back to the top viewport. I'm going to show some of the civil work elements. So first, I'm going to insert a wall here. So I'm running the wall command. I need to define the thickness or the height. There is one interesting option here, which is this pick button that lets me measure on the drawing specific dimensions. I will enable the OSNAPs. Okay. And finally, I define some justification, and I just need to select one curve or just drawing it, choosing any of these options. So I'm gonna select this point, this other corner, and finally this other corner. Okay. Back to 3D, I can see that I've chosen a different height than this other wall, and there is an interesting option in the edit panel that lets me make an object with the same properties as another one. So I will choose this copy properties from another object, select this other wall, and this will make the wall change the height, the thickness, the material, and the same properties as this other one. Okay. I just realized that the justification is not the one I wanted, but this is something that I can just change from here. Now, we can insert also some element here from the block library. So I'm going to run this command, which shows me different blocks available. So there are blocks for fountains, okay, for games, urban furniture. Also, there is a list of commercial products catalog that they offer different blocks in 3D. Okay, so you've got here some links for getting some information of their products. Okay. But I'm going to choose the games and insert one of these swings, for example. So you can insert them here. All right, so we'll move to top, show this in 2D. And we've got a project already where we have inserted zones, trees. We have created some operations on the terrains. We have some blocks. So let's insert all this data in lists. Okay, let's see all this information in lists. First of all, I'm going to run the plan list command. So we have got a list of all the species that we've got in the model. Okay, this is a list that changes live with any change on the 3D model. For example, if we change this distribution of forests back to the number of units, you will see that this value also updates. Okay, if we put this different value, we can see that the plan list also updates. If we select it, we can also change the information that is displayed. So we can also display the common name, okay, or the density, which is useful in case of the plants used in the ground covers, and other details. Also, if we need to export it, we can select this listing in the edit panel, export it, and we can save this as a HTML file or XLS for opening it in Excel. Okay. So we've got some plant lists, but also we can insert a zone list, urban block list, and also the terrain modeling list. The icon is not available so far, but we can just type the LA list terrain command also to see the different, the amount of land that has been added or subtracted from the original terrain and the area of this subdivision created with the path command. We can take a look at some other documentation tools. For example, the plan shadows is something that we can activate to see the shadows on plants in the drawing, which gives more interesting feeling. Okay, this is something that we can select and change the direction from here or the height. Okay, and change the hatch pattern. Use it for it. Also, we've got the transparency effect. Okay, I'm gonna delete them by now. Or we can see some other tools, for example, the plan label command. So we select some of the plans, and we see this label that tells us the number of units in this group of plants and the index of this species. We can edit this if we go to the label, and instead of this index, we show the initials, for example, or the common name. Okay, and of course, if we change the number of units, okay, this label will update as well. Some other options available, for example, the plant picture, plant photo. So we select some of the species. This dialog opens with Google search. Okay, but if you have some other image, you can browse it from here. So we can select this one and insert here a picture of this species. Or another thing that we can insert here is, for example, a slope. So we can run the slope command, define size of the text, and we can, for example, select this curve to get the value of the slope that is measured according to the start and end point. Okay, it doesn't take into account all the slopes in between, different change of slopes. But if you want to measure, for example, the slope from one specific point to another, so let's say that we want to measure the slope from this point to that point, we can just draw a polyline, okay, and say I want to know from this point to another, to this other, the specific slope. I can select this slope object later on and also change the size of the text. Okay. All right, so if we needed to show all this drawing already in the layout, so just need to move to the layout space, and here define the scale of the window, all right, the part of the project that you want to show, okay, and same thing for the showing the project in elevations, okay, in sections or elevations. So here we could switch to the 3D representation, all right, and show the different views on elevations of the model. I'm going back to the model space. I will put this in 3D, and we can see now some of the features of the animation commands. So first of all, I'm going to put on top of this drawing, and I'm going to use the wall mode, okay, to see how the project looks like in this interactive way. So basically, I can get closer to the project, okay, using the mouse, okay, and with the keyboard controls, I can also navigate over the project interactively as if I was there. All right, and of course, you can record what you see to present the project. So hit escape to quit this mode. And now let's take a look at how to create some short animation. So I will move to the animation tab. I'm going to turn on a layer where I've got a camera path. Okay, so I've got this curve over here. All right, this curve is in the ground floor, okay, in the XY axis. So first of all, I'm gonna project on the terrain as well. So the same thing as I did with the path, I will do it with this curve. So I select it, I go to adjust to terrain, okay, and now I'm going to move it also I'm gonna move it 2 meters, okay, above the project, the camera path. So from the animation tab, now I can select this curve as the path of the view. And here I can define also the frames per second of the animation or the total duration of it. Okay. Also, I can save this animation using a name. And here I can also decide if I want to record this using the AutoCAD display or the current renderer. Okay, in this case, the AutoCAD renderer, which will generate a render for each frame of the animation. Finally, I can preview how this looks like with this button. So I get an idea of the itinerary of this animation. All right, so you can see it's pretty easy to create an animation. Finally, I could render this scene, but I'll prefer to show some of the examples that are available in the Lands website, so you can see the different results you can obtain using this program. Of course, the results depend on how much you work on the materials, the lighting, and the scene, but you can get a very good quality results using Lens Design for AutoCAD. If you've got any questions about Lens Design, any suggestions or feedback you want to share, please don't hesitate to contact us to this email, okay? And you can use any of the learning material on the website for learning Lens Design through tutorials, videos, and webinars. Thank you very much, and enjoy Lens Design.